pleasure to introduce you to Gloria Barnet. She is an ocean adventurer, which I think sounds very, very exciting. She's also a filmmaker and a scientist and an author. She's very, very, very passionate about the importance of keeping our oceans unpolluted and also about the importance of educating people of all ages about that. So for that reason, she is very, very welcome here on Speak Up for Our Planet. And I'm very much looking forward to hearing from her. So over to you, Gloria.
Thank you very much indeed, Jane. I looked at the time. It's 5 minutes past 7:30, so I put 5 minutes on to the end of my 45 minutes. Folks, it's 45-minute talk this evening, so be prepared to be there for that length of time. I can assure you that people do say it is worth it, so there we go. Right, I hope you're going to be seeing the fact that I'm sharing my screen. Well, hello everybody. My name is Gloria Barnet, and I'm a science educator and author. I also enjoy sharing original underwater video footage with my audiences too. I'm also known as the Weird Fish Lady, but I'd like to point out that that means I'm going to talk about weird fish, and I'm not a weird lady, although my family and friends would probably want to tell you otherwise. Planet Earth, our home. It's a beautiful and complex environment. We all know that oceans cover 70% of the Earth's surface, which of course just leaves 30% for land. Let me start this talk with a bit of help for everyone to understand how important oceans are to life on Earth. This picture was taken from a satellite. It shows part of the Pacific Ocean, which is the largest ocean on the planet. It covers 32% of the Earth's surface, so it's bigger than all the land pushed together. You can see some land on this image. There's a bit of Australia, all of New Zealand, and of course the Pacific Islands sprinkled through the middle. The Pacific is enormous, and its surface covers over 64 million square miles, which is 4 times larger than the planet Mars. The Pacific Ocean Basin is the deepest of all oceans, and it holds more than 75% of the world's volcanoes. Oceans and land. 2 different worlds. Humans can't live in the ocean. To us, the oceans are an alien world. So why is it an alien world? Here I am getting ready to dive with my dive buddy, but scuba divers can only go down safely to 30 to 40 metres. That's no depth at all. Humans who want to travel deep down in the oceans use submersibles, just as astronauts use space shuttles to keep them alive. Being a scuba diver and being an astronaut have certain things in common. In both space and beneath the surface of the oceans, the environment lacks oxygen. But deep sea also doesn't have light from the sun, so it gets very cold. Deep water also creates life-threatening pressure, which can crush your lungs, and there are dangerous creatures all around you, creatures which are not in cages like a zoo. This is a natural environment. In the oceans you are weightless, and you need technology to stay alive, the same as in outer space. There are dangerous creatures with poisons and venoms and stings. This picture shows a deadly killer, and alongside him is a cute shark. Life in the oceans is beautiful, and there are incredible animals. Turtles are curious and playful. Coral is an animal, although it doesn't move around. On the coral tentacles you can see lots of small dots. Each dot is an individual coral animal. So on a reef, a community of corals can add up to thousands of creatures. And if you touch them, you can get a sting or rash on your hands. It's their defense mechanism against being eaten. The largest creature in the oceans is the blue whale. This creature is so big, its tongue is the size of an elephant. It's the largest creature in the ocean now, and it's the largest animal that has ever been on Earth. There have been no fossils found of any dinosaur that is bigger than the blue whale. This image shows the blue whale at the bottom and a skeleton of a diplodocus dinosaur at the top, and you can see just how much bigger the blue whale is compared to one of the biggest dinosaurs that ever lived. Now let's look at some of the really weird creatures that live in the ocean. This amazing fish has been called the Picasso fish because of its colourful design and its crazy stripes, rather like a Picasso painting. But not all fish are fish-shaped. There are some very weird fish in the oceans. This is a crocodile fish. Now it looks very similar to a crocodile, but if you look carefully you will see there are fins where its legs should be and a very large fin on its back. Now you probably recognise this weird fish. It's a hammerhead shark, and yes, sharks are fish. This creature has its eyes sticking out at the sides of its head. This helps the shark to see behind him as it moves through the water. Its head turns from side to side, and it can see a full 360 degrees around him. Next is a film clip of some blue spotted rays. Now, rays are cousins of the sharks, but they have developed wings instead of fins at the sides of their body, and they look like they're flying through the water. I just love watching these creatures. They're so beautiful. This is a very strange fish called a deep sea anglerfish. It lives in the pitch black darkness of the deep ocean. It's so dark he can't see the tiny fish he likes to eat, and the little fish can't see him either. Can you see the rod-like organ sticking out of the top of its head? Well, there is a light at the top of it, and this light acts like a torch. And when it's switched on, all the little fish get attracted to it and come close enough for the anglerfish to catch its meal. One of my favourite creatures is the octopus. This is not a fish, but is an invertebrate without a backbone. It's a very intelligent animal. An octopus has 8 tentacle arms, and each tentacle has a small brain to enable the tentacles to move independently. With a larger brain in its head, the octopus has a total of 9 brains. Octopus also have 3 hearts and blue blood. The female can lay up to 2,000 eggs, but then dies once the eggs have hatched. Octopus have the most amazing camouflage, and they can be very hard to find when you're looking for them underwater. Now, not all marine creatures live under the water. This is a seabird called a blue-footed booby. It can be a very funny thing to watch. It has blue feet, big blue feet, and those feet are there to attract a mate. Another marine creature which lives on the land is a marine iguana. It's a lizard, but it goes into the ocean to feed by scraping off the algae from the rocks. It has sharp claws with a 5-fingered pentastructure, very similar to the human hand. It has a blunt snout for its nose, and it sneezes out salt, which leaves a white patch on the top of his head. It can dive to a depth of 20 metres and holds its breath for about 30 minutes. Now here is a film of a marine iguana that I took in the Galapagos Islands. Watch out for when he comes back along the sand, and you'll see him sneezing to get rid of the excess salt in his body. Now I wonder if you know what sort of underwater creature this is. Well, it's actually a worm, a tube worm. In the film I'm about to show you, the worm is happily feeding. It's waving its tentacles in the water, hoping to catch some food floating past. The worm has no eyes or ears, so the worm can't see me or hear me, but it feels my vibrations in the water. As I get close, it decides to hide. This film is only 9 seconds long, so keep your eyes on it. I don't think we should look at all these weird fish, though, without seeing everyone's favourite, a Nemo fish. Actually, it's called an anemone fish, as it lives inside an anemone coral. Nemo fish have adapted their bodies to be covered in a gel-like substance. This means that the Nemos can go inside an anemone coral without getting stung by the poisonous tentacles. Only Nemo fish can live inside this type of coral, and the coral benefits from the protection that a Nemo can give by frightening off creatures that want to eat it. So this situation is called a symbiotic relationship, where both creatures are helping each other to survive. Now this is an anemone coral. The ends of the tentacles all have poisonous stings, but these two Nemo fish can live happily within the anemone coral. Why are these two Nemo fish so agitated about the presence of the camera? What is it they're trying to protect? Hang on a minute. Can you see what I can? There's a little baby. They're rushing around trying to keep the camera away from harming their little baby. Humans have had a terrible effect on our oceans. I'm sure we've all heard about plastic waste. It's bad enough looking at all the waste that humans have created on land, but when you look at it underwater, it's truly horrific. This sort of image is now called plastic soup. But the problem with the oceans is that it's not all about plastic. We have problems with oil spills, sewerage, excess heat, and too much carbon dioxide, all affecting the health of our oceans. We have giant super trawlers which are overfishing our oceans and taking all sorts of creatures into their nets, taking in creatures like dolphins and turtles. Their fishing nets catch far more than is needed, and bottom trawling is tearing the seabed apart. The nets are so large that it's estimated that these nets are catching up to 440 tonnes every time they put the nets in the water. Things are getting so worrying that I have to ask the question, are we the last generation to eat fish? Why do we need our oceans to be healthy? Why is it so important? Seagrass is the only plant in the ocean. It's just like the grass you have on your lawn or on the local football pitch. But seagrass doesn't mind living in salty water. Because it's a plant, seagrass makes oxygen and glucose by photosynthesizing. Seagrass releases oxygen into the atmosphere, supplying 10% of the oxygen in our air. The smallest living things in the sea are algae, not animals. These are diatoms. They're magnified 8,000 times, and they join together to make plankton. Plankton is the most important living thing on Earth. This image has been taken from space, and it's looking down at an ocean where you can see the green algae floating near the surface. Seaweed is not a plant. It's actually an algae. The most important algae in the ocean is plankton, because plankton produces up to 70% of all of our planet's oxygen. It releases it into the atmosphere. So oceans with seagrass and plankton provide 80% of all of Earth's oxygen in the atmosphere, and 99% of all life on Earth uses oxygen to survive. The oceans not only supply our essential oxygen and release it into the atmosphere, the oceans also absorb carbon dioxide. Oceans are known as a carbon sink, and in fact they are the largest carbon sink on Earth. Carbon dioxide has been produced naturally on Earth from volcanic eruptions for millions of years. Humans have been pushing out waste carbon dioxide since the Industrial Revolution, and the amount of carbon dioxide in our atmosphere now is at very dangerous levels. We can see in this graph the effects that humans have made. Since 1850, all the lines on this graph are going up. The lines are made up of coal, gas, petroleum, all being burnt and producing CO2. The black line is the total of all those fossil fuels. You can see there are millions of metric tons of carbon being produced every year. Since the Second World War in 1946, humans have burnt fossil fuels, producing vast quantities of CO2 in the atmosphere. This excess carbon dioxide produces heat, and you can see from these pictures the before and after of what happens when too much CO2 creates excessive heat in the oceans. You can see the damage it's being done to the coral reefs here. The before is beautiful, healthy coral reef. The after is a dead reef. CO2 gas absorbed by the oceans also turns to carbonic acid and is turning the ocean acidic. The acidity is causing plankton to die. And of course, plankton and seagrass are producing 80% of our oxygen on Earth. By burning fossil fuels, humans are actually killing the source of our oxygen used by all life on Earth. We need healthy oceans because we know oceans are home to millions of species of amazing animals, as well as loads of different life forms we still have to discover. Oceans supply 80% of the oxygen in our atmosphere. Without the oxygen being produced by the oceans, all life on Earth would become extinct. For years we've been seeing cartoons like this, but in fact this cartoon is wrong. It's not the planet that will be destroyed, it's the life on Earth that will be affected. Life on Earth will become extinct. But we can save the life on our planet. I believe we can. I'm a climate change optimist. I believe that the technology we have already developed is enough to be able to save the life on this planet. We have the technology and we have the scientists. We just have to learn to use what we've developed. For instance, there is a great shortage of drinking water on the planet, with 2/3 of the world's population facing water shortages by 2025. But there is an invention which will turn seawater into drinking water. We just need to get this system working where it's needed. And don't worry, once the seawater has been turned into a glass of drinking water for humans, that water will eventually return to the water cycle and will end up back in the ocean. There are new technologies with biofuels made from algae, solar panels placed in the deserts. In Holland, the electric trains are fueled by wind energy, and there are turbines which create energy being put underwater around the coasts of the UK, at depths which don't threaten shipping. Can we save the life on our planet? Can we change human thinking? After the first major lockdown caused by COVID in 2020, everyone seemed desperate to return to normal. But I don't want to return to the normal that existed before 2020. I want to be part of the new future of the world, where we all change our way of thinking and act differently from the selfish humanity we were before COVID. I want to move forward and change the way we live our lives. This cartoon sums up what is the worst of the previous normal. Here we are with a small boy heading for a world without oxygen and without anything green and natural around him, whilst his father thinks everything can be cured with money. This statement is one of my favourites. Never doubt that a small group of people can change the world. But what can individuals do? Well, we can all reduce our carbon footprint, reduce our carbon emissions, use the bus, use renewable energy where we can, and change our diets to include more plants. We still have to care for the oceans, of course, to enable our oxygen supply to continue, so we still need to reduce our use of plastics. Avoiding consumerism is important too. We all buy too much stuff. Consumerism is unsustainable in the way we presently lead our throwaway society, so if you don't need it, then don't buy it. This cartoon is close to the truth. We do have to rely on a responsible government to take the right decisions, to get everyone working together in the right direction. But if we wait just for the government action, then it will be too late. Although we can all act as individuals to improve our carbon emissions, that might still be too slow. So I'm going to emphasise the need for us all to work together as communities. I believe everything starts with education. We need the knowledge of what we're facing and how we can help. We need to help educate both young and old. We need to set an example to others and share what we do when it's successful. I volunteer to work with Footprint to the Future, which is a social enterprise run by volunteers. We produce educational resources to help children and grown-ups to learn about the importance of keeping the oceans healthy. Footprint to the Future has published teachers' resources and books, both non-fiction and fiction, for all ages. The books for 8 to 12-year-olds are adventure stories, but the children who read these books are learning the science behind the adventures, from saving sea life from plastics or protection of ocean life and habitats, to the problems with overfishing. The change in thinking we need to happen can only be achieved if we educate both young and old. I can't do it all by myself, so talk to me and see what we've produced, and buy some resources for you to gift to your local primary schools. Education, education, education. I really believe that is the answer. The next film clip was taken in the Red Sea in Egypt. It's a hawksbill turtle. But when it first came up to me, I thought it was trying to kiss the camera. But perhaps it was trying to tell me something. Perhaps it was encouraging me to talk to you all about looking after the oceans, to keep it healthy for this turtle and all his fishy friends. Only if we all join together as a community will change really happen. But it all starts with you. Will you commit to changing your way of life for a more sustainable future? And if not you, then who? And if not now, then when? Finally, in the last 2 minutes of this talk, come diving with me. Come underwater and see the ocean world for yourselves. I'm going to take you diving on a wreck in the Red Sea. This ship sank in 1874, but you can still see the shape of the ship. The whole ship is covered in coral, and the wreck has become a coral reef. The reef is now home to hundreds of ocean creatures who are seeking protection from predators or strong currents. There are many beautiful creatures, like this raccoon butterfly fish. There are so many species living here. There is a striped regal angelfish and a freckled hawkfish, which doesn't like us coming too close. There are immense communities of coral, such as this large table coral made of hard staghorn coral. But you can still see the old metal structures from the wreck. A shoal with hundreds of yellow snappers allows me to take you through the middle of them. And this is a nasty piece of rusty old metal. We'd better keep clear of that. Beneath the next shoal you can see pipes, and there is a large fish hiding behind the shoal. It's harmless, it's just a very docile squirrel fish. Here's a giant moray eel. It has a cleaner fish on its back picking off small parasites from the moray's skin. A shoal of orange antheas get excited by our visit, and a large surgeonfish joins in. It gets its name because of the sharp knife-like fin near its tail. Thank you for listening, everybody, and thank you for inviting me to speak to you today. Please contact me through the website or email gloria@barnetauthor.co.uk. I'd love to hear from you. Go, folks. I will stop sharing. And you should be able to see
you again.
Okay.
Great. Thank you very much indeed, Gloria. That was terrific. I'm sure many of us did learn something new, and I certainly enjoyed all of your pictures of the weird and wonderful creatures under the ocean. I've done a tiny bit of scuba diving myself, but nothing like that. So absolutely amazing. Thank you very much indeed. Shall we all give Gloria a round of applause, whether we can hear you or not?
Thank you very much indeed. Thank
Rounds
you.
of applause when everybody's muted are always a little bit sad, but anyway. So that was terrific. Thank you very much indeed. If anybody has questions, please feel free to ask. Probably put them in the chat is the best way, just so that we can see what people have asked. But if you prefer to put your hand up and ask, then I will switch. So I've got my gallery view. Marcus has got a clapping sign rather than a hand up, I believe. So,
unmute yourself, Marcus, if you wanted to talk.
I think he was just
William at the top. William. She's yeah. Go on then, William.
William, yeah, can I? Yeah. Right, I learned something that really did surprise me, because I've read, what they say, a dozen books. I read all the articles, I read IPC reports, and I've never read about this loss of oxygen. It seems to either pass me by, or not a lot has actually been written about it. Can you say something about, if you like, the timescales or the tipping points for this loss? At what warming are we in serious danger of losing oxygen?
Yeah, that's the problem, and this is the problem. What is the reason why people don't talk about it? People can join the dots. Scientists join the dots in that, you know, the sea is giving us our oxygen, but the sea is becoming acidic, and that plankton is going to die. We can all make those assumptions. What nobody can do, and that's why they don't talk about it, because people say, well, why don't the scientists tell us? They can't. The ocean is so vast. How much plankton is there? Yeah, how much acid is actually in the water? We have a few very small number, but really important numbers of things being reported. For instance, Vancouver, in the waters of Vancouver, the people who were growing oysters in the water there have moved to Hawaii because the shells were melting. They were, you know, becoming so soft that they weren't growing the oysters anymore. So there were a number of different things like that all over the world happening, but little tiny pockets. So what I'm doing when I'm talking about this is throwing it out and saying, look, just join the dots. If that is what's going to happen, by the time you get enough scientific evidence and data, you're going to be too late, because the oceans will be full of acid. And by that time, the oxygen will be being reduced. So I'm trying to say to people now, come on, think about it. What makes sense? You know, and that, William, is my position on it. You cannot find very many scientific reports on it, because they can't. I mean, they can't even tell, you know, the amount of plankton. I mean, they did a survey in the Indian Ocean, and they thought, I'm fairly certain, that there was about 30% less plankton in one particular year, but they couldn't tell exactly, and the data is just terrible, really. A good scientist wouldn't work with it. You see what I mean?
Thank you.
Peter.
Yeah, thank you. Gloria.
My question is, what specific actions do you recommend to have a direct impact on ocean health, as opposed to the more general things that you were recommending?
Yeah, I mean, ocean health is heat, too much heat, and too much acid. Both of those are coming from too much CO2 in the atmosphere. So it's fossil fuels. If we can get rid of fossil fuels, and I'm not saying get rid, just reduce it. I'm saying get rid completely. Then the less we're putting out into the atmosphere, then the less that the oceans have to themselves try and take in as a carbon sink. I mean, lots of scientists are working. There are scientists working on growing coral that is adapted to heat, and then they're replanting it, as it were, you know, putting it back on coral reefs where it's died off, and that sort of thing. So if we can stop the CO2 getting into the atmosphere, then that blood transfusion of taking, you know, that you know, there's no point in having people say, oh, I'm going to plant a tree, if they can't stop the leakage of blood, or in this case, the output of CO2.
So what people should be doing is to write to their MP and write to everybody they can think of to anything,
you know, what they've done with Russia at the moment is to stop them using things. So I would say, go and find out what your bank does. And if all of us actually stopped using the banks that are still supplying oil money and lots of things like that, there's still banks that are very involved with fossil fuels. And what I've done is I've changed my bank. And if we all changed our bank, we would create a ripple in the ocean, if not a dirty great wave. So, you know, let's start with something like that. We've got to work at, and the scientists, they've done so much about producing anti-fossil fuel, you know, stuff. We've got renewables that are really working. And don't let anyone tell you that they don't work, because they do. They really, really do.
So there's a talk on the Speak Up for Our Planet website, which was probably better part of a year ago now. But
find out what your bank does. And if all of us actually stopped using the banks that are still supplying oil money and lots of things like that, there's still banks that are very involved with fossil fuels. And what I've done is I've changed my bank. And if we all changed our bank, we would create a ripple in the ocean, if not a dirty great wave. So, you know, let's start with something like that. We've got to work at, and the scientists, they've done so much about producing anti-fossil fuel, you know, stuff. We've got renewables that are really working. And don't let anyone tell you that they don't work, because they do. They really, really do.
So there's a talk on the Speak Up for Our Planet website, which was probably better part of a year ago now, but it'll still be relevant, from 3 people telling you how to check where your pension is invested and how to do something about it if it's not invested in the right place.
Yep, so all of that sort of thing. It's like the sanctions we're giving to Russia. If it hurts somebody in their pocket, then they might do something about it. I'm doing this talk tonight. Tomorrow morning, I'm in a primary school, so that's another one for Peter to make a note of. I'm in primary schools all over the place.
Okay, well done, Gloria, and keep talking to those people on the ocean liners, and let's hope that somebody's listening to you and is gonna get rid of oil. Wouldn't that be wonderful?
Wouldn't it just? Yeah.
So thank you very much. Thank you everybody for coming and for listening, and do tell people about Speak Up for Our Planet, because we're still going strong and we'll do lots more talks. And we have a regular newsletter which gives you information about what's been planned next. So if you're listening to this because somebody gave you the link but you're not signed up for the newsletter, then the information's she too is a diver and an educator and a great supporter of environmental education. So she's very much on the same page as you.